I came here the other day to record a brief video about the start of the Rotten Calder. So there's a pipe here, the water comes out of the pipe. Above the pipe we basically have some clear-felled forestry. Until 6 months ago it was long-standing pine forestry. Now it's been clear-felled and it's a large open area. And as I saw the water coming through the pipe, the first time it came to an obstruction, I saw white foam and brown on top of it. And my thought was, how can this be polluted so far upstream? It's come almost no distance. I went home and I did my research and discovered that that's not pollution at all. The pine itself adds tannins and anti-surfactants to the water, and it becomes what they call volatile organic compounds. And in fact, it's a sign of a healthy young stream. Now that foam can be seen all the way down the river. I don't see any today, but the water level is considerably lower. But what I'm going to do is I'm going to go all the way from source here, up at Ardrochrig, south of East Kilbride, to the River Clyde, and I'm going to collect water samples and we're going to test them just to see if there are any farming pollutants in there, or if this little lowland stream is as clean and clear as we like to believe Scottish water is. One thing I can say about the water is it's brown. So that will be interesting. I suspect that is because we're on peat here, and it's going to flow down through peat and through farmland and through some old industrial areas, and we'll see what happens to the water. But this will be interesting when we test it. We might even look under a microscope and see what's hiding in there. So our second sample is coming from the Rotten Calder, about 200 metres upstream of Flat Bridge on the edge of East Kilbride. So that's just before it enters Calder Glen Country Park. And it's wound its way roughly 300 feet, 100 metres, downhill from its start, through grazing land, through a little bit of forestry, and through mostly arable farmland, but farmland where they grow grass and where the primary fertiliser that's used is liquid animal manure. It's slurry. So I'm not expecting an awful lot of chemicals to be added. Looking at the water here, I don't see any signs of kind of any scum or bubbles, but then it's slow flowing, but there's nothing to block it. So I'm going to take a sample here and then move on downstream to the other side of the country park. This is what we're talking about. This brown, foamy goop with stuff piled on top of it, swirling round in little pools like this, caught in an eddy, and in this case, trapped by a tree that's come down across the river and then has turned into a bit of a dam. This looks bad. This looks like man-made pollution, but it's not man-made pollution. Sure, if somebody had put a detergent, a surfactant chemical into the river above this point, then it would have this effect. If I were to go and squeeze in some fairy liquid, I'd get this. That's because fairy liquid and natural VOCs are both surfactants. Surfactants are a chemical where one end likes water and one end doesn't like water, it likes oil, and they can be produced naturally by decaying leaves, decaying wildlife, decaying pine needles especially. That's what causes the brown and the tannin. And then that causes the same effect you'd get if you put bubble bath under a running bath. So it causes the air to be trapped inside and foam to be made up. It's not bad, it's a sign of a healthy ecosystem. Any turbulence in the river, such as here at Horseshoe Falls and the Horseshoe Bridge in Calder Glen Country Park, whips up the surface of the water, and again, just like bubble bath, creates a frothy surface, which in this case slowly runs down until it's trapped behind that tree and builds up that thick layer of brown bubbles. So for our third sample, I've chosen to take it at Millhaw Bridge. Millhaw Bridge is the last bridge in the Rotten Calder Gorge. We start at Flat Bridge up at the top, and it comes down through the country park and then past the delightful Cross-Basket Castle. Basically, it runs through the deep stony gorge all the way. At Millhill Bridge, our territory changes. We go into what's now farmland, but was for hundreds of years industrial land, coal mining, brick making, iron making. And so I want to see if that impacts the water quality at all. But for now, I'm going to take a sample here at Millhill Bridge, sample number 3, and we'll see if coming through all that forestry has had any impact. Looks fairly clean. For my last sample, I'm standing next to the last bridge over the Rotten Calder. This is the little iron bridge which would have taken people from the village of Calder Vale over to Newton to go to school. If we look at the surface of the river, we can see lots of little white foamy spots floating down. It's very still, it's very quiet, there's nothing catching them. So here I'm going to get my last sample, which we can then take back to the lab and test. Behind me, that bridge carries the West Coast Main Line. So if you ever come up to Scotland, just before you get to Glasgow, you'll pass over that bridge, this river, and perhaps you'll see the little iron footbridge next to me. Since it left the steep valley of Calder Glen, this has come through landscape which is now farming, it's now arable farming, it's now some animal farming. But for many, many years, it was the heart of Scotland's industrial region. So I suspect in those days, lots of pollution would come down here. Not very far down this stream, it joins the River Clyde. And the River Clyde for years was biologically dead because of all of the mills and ironworks and linen works and other industries further up the river in Lanarkshire. I'm pleased to report now that the River Clyde, as you can see, is absolutely beautiful. On the right-hand side of the picture, you can see the Calder joining it, and you can see the nice green grasses and reeds growing in the Clyde as it passes between Uddingston and Glasgow. Stop recording. So for those of you that stuck around to the end and would like to see what the results of those water samples are, let's do it. Maybe not unexpectedly, the pH of the water at the start as it's come through the pine forest and the peat is very, very acid in the grand scheme of things. I'd say that's a pH of about 6. And then as it gets downhill, it gets a bit greener. I'd say that's probably a kind of neutral 7 to 7.2, and then a very slight alkaline for the last 2 samples. So that's unexpected. I knew that we had acid water around here as somebody who keeps fish, but I did not expect it to change that dramatically towards kind of neutral and slightly alkaline. So for our second test, we're going to test for nitrates, and we are hoping really to find little to no nitrates. But the nitrate levels may creep up as we go down the river. But bear in mind that we saw the most of the foam and the scum at the top. So we can see fairly conclusively that the nitrate levels dissolved in the water are effectively 0 at all points, which is exactly what we want to see. So we don't have any industrial pollution in there. All of that brown foam, or all of that white foam with the brown scum on top of it, is entirely natural